Hi guys, Happy New Year and welcome to our channel of Sciences and Mathematics. Today we are going to look at a topic in mathematics by the name calculus. Of course, we are going to see that this concept of calculus is very important for us, especially in this modern age and time. This is because, of course, we have a lot of advancements both in science and technology. And also we're going to look at this branch of mathematics that deals with the rate of change is very much relevant and applicable in different model systems where there is change. So in that case, we are going to see these concepts, of course, that we are trying to mention being applicable in telecommunication systems, in computer science, engineering, medicine, pharmacology, and even in business. So in that case, of course, we are going to see that in some applications like in mathematics that require the determination of the rate of change, like in determining velocity, acceleration, and even the position of the object, this concept of calculus is going to be very handy. And also in topics like physics, specifically in determining the behavior of electrical and magnetic fields, this is going to be also to be one of the most relevant parts, or one that is very handy in trying to determine the concepts that we have mentioned. Of course, apart from others areas that we're going to see as we go by in this specific topic, we're also going to see that there might be some new areas which we are going to discuss. Of course, we shall mention in case we come across them. So in this case, for today's topic, we're just going to be biased on trying to look at some of the symbols that we use in calculus, especially the one that we're going to encounter as we come across the topics. This is very important because, as we know, the symbols bear some significance. They're going to assist us in trying to figure out how some of the problems might be solved in this concept of calculus. So without further ado, thank you and welcome. So as I've mentioned, today we're going to do a topic in mathematics, which is an introductory part of the concept of calculus. And we're going to see that the different symbols that I've mentioned are going to be applicable in various areas of this subject as we go by. So in that case, we shall start by the definition of the term calculus. So in this case, calculus refers to the study of the rate of change. This basically is a branch of mathematics. This is a branch of mathematics that deals with study of the rate of change. This is the main concept because as we are going to look at other areas, of course, we have different variations of the definition of this term that we call calculus in different texts. But in this case, of course, it's generally can be regarded simply as the study of the rate of change. Now, in other definitions, you can find that it's a branch of mathematics that deals with the findings and properties of derivatives, and integrals. So these are new terms that we're going to encounter as we go by in our topic, in that a definition for this calculus can be defined as a branch of mathematics that deals with the findings and properties of derivatives and integrals. And this, of course, is maybe based on some methods of summation of infinitesimal differences. So this term infinitesimal means very small differences. Of course, we are going to see that we're going to use this kind of a symbol maybe to denote a small change maybe in the x or the y variable. So in that case, that's a simple definition of the term calculus. Now, calculus as a branch of mathematics is made up of two main areas. Of course, the first one is going to be integral, and the second one is differential calculus. So as we're going to go by in our lesson, we're going to find out that there are two specific areas that we're going to look at in this topic of calculus. Now, the first one is, as I've said, differential calculus, and the second one is going to be integral calculus. So as I've mentioned, that calculus is a branch of mathematics that deals with the properties and of course the findings of derivatives and integrals. So it goes without saying that of course this differential and integral calculus are branches of mathematics. So for that case, as I've said, there are common symbols that are used in this branch of mathematics that we have called calculus, and we're going to look at a few of them in order for us to try and understand, in case we come across them, what these symbols imply or stand for. So in that case, the first one we're going to look at is the symbol that is F colon, and then there's X, Y. Now this symbol is an F colon X, and then there's an arrow that starts with there's an arrow that starts with this symbol here, and then it points towards Y. Now this symbol indicates that it's a function of F. It's a function F maps X onto Y. So which is this refers to a function F that maps X onto Y. So in case we come across such a kind of symbols, we're going to know that maybe this is what it refers to, that it's a symbol, it's a function of F that maps X onto Y. So this symbol refers to as maps X onto Y. Now the second symbol is F of X. Now this one refers to the image of X under the mapping of F. So this is the image of F under mapping of this is image of X under mapping of F. So in this case, of course, this is a symbol that we're going to refer later as a function, but of course in simple terms it refers to as output of F when the input is X. So this one as well, we can say that it's output of F when input is X. So we're going to see how these ones, of course, are given in a broader interpretation. But of course, when we come across such a kind of a symbol in calculus, then we shall know that we will know that it's an image of X under the mapping of F, or the output of F when the input is X. Of course, we're going to see at the concept of independent and dependent variables later in some of the units, of course, which we are going to relate to this. So there's another symbol that is number 3, that is F, of course, and there's that superscript that is a negative over there, but we're going to give it as a name. So this one refers to the inverse of a function F. So that one refers to as inverse of F. So that symbol refers to inverse of F. And we might have another symbol that is GF. So this one, of course, can have an interchange of FG. So this one generally refers to the function of F followed by a function of G. So this is can be a function of G followed by function of F. I've said this one can be as well be interchanged in other cases where F and G starts first, but of course we're going to see maybe in case as I've said we come across those. And then we shall have a symbol that has to of course symbols on letters aside that encloses that letter X. Can it be a letter, maybe an alphabetical letter, or maybe a symbol that we're going to see later in case we come across one. And then that is that refers to the magnitude of X. Magnitude of X. So magnitude of X, mostly these are just an absolute value, and we're going to see maybe in case we come across. So there's another one that I'm going to write here that has got square brackets. Now this one refers to the integral part of X. This is the integral. We mentioned about the integrals and derivatives. So this one refers to the integral part of X. integral part of x, and then we shall have maybe this one we are going to deal with it, the topic of logarithms and indices. Of course, we have done it in one of our videos. I'm going to put a link in the description box on this. So this is of course refers to the logarithm to base a of x. This is logarithms and indices. So this is logarithm to base a of x. So these are some of the common symbols that we're going to encounter in calculus. Of course, I've said that there might be others which I've not mentioned, but as we come across them, we shall be mentioning them and their relevance. So apart from these symbols, there are other symbols that we might encounter, what we call limits in derivatives and integrals, and it will be okay for us as well to try and find them. So in a quick recap, f dot, this is a colon, x, and then there's an arrow that has got a slash behind there, y, refers to the function that maps x onto y. F of x, which we are going to refer to as a function, is the image of x under the mapping of f, or it can generally be referred to as output of f when input is x. Let's say that we're going to look at the dependent and independent variables in some of the expressions that we're going to talk about or graphing. So in that case, the third one we said is this f that has got a negative superscript there, inverse of f. This symbol refers to the inverse of f. And then g of f, I said they can be interchanged. That's a function of g followed by a function of f. It's a combination of two functions, so that x into the two slashes there refers to the magnitude of x, and then the integral part of x is given by those square brackets, and then lastly I've talked about the logarithm to base a of x is given by that expression. So then next we are going to look at the second part of it, and the last one we're going to look at the symbols that are used for limits, for derivatives and integrals. Now that we say the two main parts of calculus, branches of calculus, is integral and differential calculus, we're going to see also the expressions and some of the symbols that are used in for both the derivatives and integrals. So the first symbol that we're going to look at is still this arrow. Now in case this arrow appears in our discussions for one of the arrow, maybe an expression, then this one refers to tends to. So maybe if it is mn, then I can say that m tends to n. So that is what it refers to. And then the second expression, that one, or the symbol under the limits, under the derivatives and the integrals, that one refers to becomes unlimitedly large or tends to infinity. So this one refers to tends to infinity. Maybe a number tends to infinity, a numerical figure, or maybe a symbol tends, or maybe an alphabetical letter that implies, or which is an expression, tends to infinity. Next, this is a term that is used. Now this term LIM refers to the term limit. Of course, we're going to see what a limit is, but in this expression, it is written as the short term for limit LIM, and then there's x a f of x. Now that we have said that f of x refers to a function, so in this case, this expression implies the limit as of fx, the limit of fx as x tends to a. So this one refers to the limit of fx as x tends to, I hope it's as x tends to a. So in this case, of course, we can just use this arrow that we have already mentioned in our first expression. So it's a limit of fx as x tends to a. So that is the first use of that symbol. And then we have another one, the limit as x tends to. This one has been given a positive. Of course, we shall get a meaning to that. This one implies the limit of a function fx as x tends to a from above. So this is a limit of fx as a as x tends to a from above. Of course, the subsequent symbol for that one, of course, we shall have one that has got bears or with a negative sign, which implies the opposite of this. Now we can just write and say the limit. Now the limit of as x tends to a negative of a function fx. So this one has the same meaning, only that at this point it is a from below. So this is the limit of fx, the limit of fx as x tends to a from below. So that is what that particular expression implies. And then we have another one. Of course, I talked about in one of the definitions of calculus, I talked about infinitesimal differences. So these are the slight increment in maybe can be x and y, as I've denoted there. So this one, basically, this symbol that I've written there, sigma, I hope, refers to the slight change or increment in x or y. Can be another figure. So in that case, in case we come across that symbol, it refers to the slight incremental change. And then we have, of course, we talked about one of the symbols that we were talking about, the inverse, that had a superscript, a small superscript of -1, but now we are going to have f prime with that one of a function or dy over dx. So those two symbols refer to the same thing. So this one refers to as a derivative. This one indicates a derivative in case we come across it in any of the functions that we're going to deal with in calculus. And then now that we have looked at this, arrow with that symbol tends to infinity, and the limit, of course, of a function fx as x tends to a, the limit of fx as x tends to a from above for a positive sign, for the negative sign as x tends to a from below, and then those small sigma signs indicate a slight increment in x and y, and then there's a derivative of function. So I'm going to do away with this so that we can do last bit of these signs or the symbols. So that case, we shall have another symbol. Of course, I've given fx prime, f prime, so f prime prime x or d squared y over dx squared. So this one refers to the second derivative. Of course, there's space here. This refers to the second derivative, maybe one expression, a term, etc. So we're going to see. And then we shall look at this one symbol. This is AB. This is fx dx. Now this one refers to the definite integral or an area beneath a function fx from x equals a to x equals b. So basically we're going to give this one as a definite integral. Now definite integral refers to as an area beneath the function fx from a to b. These are the values for x. Of course, we said that this one we are giving it as a definition. Now in that case, for the values of x from a to b, you find that the area of the change that has been defined there will appear the area beneath the function fx. We are going to see that in one of the demonstrations that we're going to do. So for that case, we have a second symbol like that, fx dx. That one refers to as indefinite integral. Indefinite integral, or just a primitive. Primitive. So that's an indefinite integral or primitive, as we're going to see. Now this symbol, so just to mention it slightly, this is an elongation of the alphabetical letter S, of course, which stands for the term sum. Sum, which means the totality of something. So these are some of the symbols that we're going to come across in dealing with calculus, and we're going to see that they are going to be very much important for us now that we are trying to allocate meaning to them. So in that case, of course, we shall come to the end of those definition for symbols. I hope that they are going to assist us, and we shall keep on doing a reference to this particular video in case we need to find an elaboration for one or two of the symbols that we may come across. So for that case, that is it for today. Thank you guys. Bye. God bless you.